Hello everyone, my name is Vijay. So today we are going to talk about application that I have made. Basically, it's a file sharing application made using WebRTC. So first we'll look at the demo, then I will explain what was my thought process and what things I have used to make it. So I have opened two tabs. In both, I have opened the application. So the sender will first create the room, then you will copy the code and the receiver will paste it to join the room. So after establishing a connection, the sender will choose a file, whatever he wants to share with the receiver, and yeah, the receiver will get it. He can at start he can also choose a folder where the file will directly get saved, which will save the memory from your browser. Or if the file is small, don't care about it, directly let it be default and you can download it in your disk. Okay, so now let's talk about the planning for this application. So the problem was, um, there is very less option to share big files through internet. The first option is WhatsApp. You can share fixed size of file through WhatsApp. Media is heavily compressed and they lose quality. Then we have mail. In mail, again we can share fixed size of file, but if the file is big, then we need to upload it to drive, then attach it. Okay, then we have uh, another option, that is compress big file and share. Yeah, lot of work, right? So my initial idea was, we'll create a platform where user will first connect, then can share the file. So the file will get stored in a server like a DB, then will get delivered to target. After that, the file should get deleted from that DB. Uh, the tech stack I thought about was OnePlus Express for backend. Then for storage, we'll use Cloud R2 because it has no ingress fees. Then React for frontend, right? Uh, for connecting users, we will create session. Then through some unique link or code, we will connect the users. Then we'll store the file in DB and share it to the target. Then what happened was, one day I was revising all protocols and all, and one of them was WebRTC. Yeah, so it is used for peer-to-peer connection, where we create a data channel and we can, you know, we can do video conferencing. Also, one of the application is we can share the data, we can transfer data, and there I got clicked that we can use this protocol technique in this application. And there are many apps or application which use the same protocol, but I wanted to explore WebRTC, all the protocols it has, and it's very interesting. After I learned, it's like very interesting domain. And one of the benefit is, the data is end-to-end encrypted in WebRTC. No one sees the data, else sender and receiver. So the now idea is we'll connect to users directly and transfer file through WebRTC. No need of database, no need to worry about user matching. That is also handled by WebRTC. It's very fast, it's very secure. Now let's talk about system design. First of all, the function requirement. There is only two function requirement, that is connect with the user unique with using unique code and then transfer the file from one user to another. And non-functional requirements are, first of all, low latency to connect, right? Within 1 second we have to connect to the user. Then file transfer, the speed will be 5 to 8 Mbps, which is enough for big file also. I've tried sending a 2 GB file and it works good. I guess within 2 minutes or something we can send that. Then uh, I, I wanted an application that will be free to host and run, to save my resources. Then preferring availability over consistency. We talk about this on non-functional requirement, because it's not any banking application, right? Where consistency matters. So the preference goes to availability. Then about design. First of all, the P2P Sender app will have backend and frontend. The frontend are just HTML and CSS and JS file. Main work is done by JSS. There are three files: signaling client, WebRTC manager, and file transfer engine. Signaling client has responsibility of connecting, connecting to user and handling this signaling process like connected, not connected, failed, and all. Then WebRTC manager basically manages all protocols like SDP, IC, and all. Then we have file transfer engine, which is basically manages the sender file logic and receiver logic for receiving the file and all. Then this all static files are served using Hono static serving technology, right? Then we also have turn or stun config in the application. We have our own turn server deployed in some actually Oracle Cloud. Then we have WebSocket, which talks to the front end. It helps in signaling client and all to like talk if whether we are connected or connecting or disconnected and all. Then if then that then this application when a browser user comes and open a browser, the sender will create a room, will wait or to get a client, then he will send file, and again he will get ready to send more. And another person who is a receiver will join the room, receive file, and download with one click. And this is done using creating a data channel, WebRTC data channel, which is encrypted for file transfer. Yeah. So now let's talk about entities. We have only one entity in this whole system design, that is file. And we're also not saving it anywhere. It's just an entity which is transferred using WebRTC data channel. So file can be anything: video, pic, text, Excel, no format constraint. It doesn't matter, right? Because it will be converted into chunks, bytes while transferring, and then we will convert back to original form using the metadata of the file. And then let's talk about some terms. In WebRTC, we'll always hear about stun and turn. So what is stun? Session traversal utility for NAT. It's a lightweight, free, and it is used to know the public IP address of both the user. Yeah, that's the main function of it. It is not effective against symmetric nets. So what is NAT? It is a network address translation. Basically, it maps private or internal IPs to public external IPs. So when we have symmetric NAT, which is used widely, stun is not sufficient. We need turn servers. So what turn does is it is a traverser using relays around NAT. Relays. So it relays a media or data between peers when direct path fails, bypassing strict firewalls. So we are using only stun server. What happens is if there is a user 1, user 2, there is a stun server. User 1 requests the IP address of the another user. It gets that and it establishes a direct communication between the users. But when stun fails, what happens is if there are two users and a turn server, then the communication happens through the turn server. There is no direct communication, but it happens through the turn server, because the IP addresses are very hard to find when there is symmetric NAT. Then in backend, we had no, in front end we had WebSocket signaling. Sorry, backend we had WebSocket signaling, which handles signaling messages for peer discovery and HDP/IC exchange. And what is HDP? It is session description protocol. IC is interactive candidate interactive conversation establishment. That both are the fundamental protocols of WebRTC. Then in front end we have two files, that is signaling client, main files, that is signaling client, which manages WebSocket connections and negotiate messages like connected, not connected, connecting, and all. Then WebRTC manager, it handles IC candidates. What are IC candidates? that are basically a combination of IP address plus port, which is handled by WebRTC manager. Then HTTP offer or answer means session description protocol, which describe your session and all. Then data channel setup, through which our data will be transferred. So I guess I have explained the project well, and if you liked it, please subscribe and like. Thank you.